Hello and a very warm welcome to today's session. I am Rashmi, working as Assistant Professor, Department of Physics. Today we are discussing about Unit number 7, Electromagnetism, which is a part of your 4th semester Physics, Paper 4, Electricity and Electromagnetic Theory. In the previous session, I had given a brief introduction about electromagnetism and we had also discussed about electric charges. In this particular session, we will be finding out what will be the effect of magnetic force on a moving charge, and we'll also discuss about a very interesting force called Lorentz force. So let us look back at the key points of last session. In the last session, we had discussed that if there is a charge which is at rest, it is going to produce a electric field. And if the charge starts moving with a velocity v without accelerating, then it is going to produce electricity as well as magnetic field. And if the charge starts accelerating along with the electric and magnetic force, it is going to emit electromagnetic radiation. So ಕಳೆದ ಕ್ಲಾಸಲ್ಲಿ ನಾವು ನೋಡಿದ್ವಿ ಒಂದು ಚಾರ್ಜ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಅದು ಕೇವಲ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ ಮಾತ್ರ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಅದೇ ಒಂದು ಚಾರ್ಜು ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ವೆಲಾಸಿಟಿಯಲ್ಲಿ ಮೂವ್ ಆಗಬೇಕಾದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಜೊತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ನ ಕೂಡ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಅದೇ ಒಂದು ಚಾರ್ಜ್ ಆಕ್ಸಲರೇಟ್ ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಜೊತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡೋದಲ್ದಿರ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್ ನ ಕೂಡ ಎಮಿಟ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು ಕಳೆದ ಕ್ಲಾಸಲ್ಲಿ ನೋಡಿದ್ವಿ, ರೈಟ್? And I also told you that we are not talking about the electromagnetic radiation. We will be focusing only on the second point, which is a moving charge produces magnetic field. Moving charge anta heladre, a charge at motion is nothing but current. So current is nothing but rate of flow of charges. So our interest is all about the magnetic field that is produced by a current carrying conductor. Okay. Also, we had discussed about electric fields and electric forces in our previous session. In today's session, let us talk more about magnetic fields and magnetic forces. What is a magnetic field? How do you define a magnetic field? Just like electric field, we define a space around a magnet or a current carrying conductor where a magnetic needle experiences a force. So what is magnetic field? It is the space around a magnet or a current carrying conductor where a magnetic needle experiences a force. Magnetic field ಅನ್ನ ನಾವು ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? ಅದು ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಅಥವಾ ಒಂದು ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್ ಸುತ್ತ ಇರುವಂತಹ ಜಾಗ. ಆ ಜಾಗದಲ್ಲಿ ಏನಾಗಬೇಕು? ಇಫ್ ಯು ಬ್ರಿಂಗ್ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ನೀಡಲ್ ಕ್ಲೋಸ್ ಟು ದ್ಯಾಟ್, ಇಟ್ ಶುಡ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಅ ಫೋರ್ಸ್. If it experiences a force, then we'll say there is a magnetic field at this particular point. If it is not showing any deflection, then we'll say there is no magnetic field. So in order to define a magnetic field, we have to talk about magnetic force. Magnetic field ಇದೆಯೋ ಇಲ್ವೋ ಅನ್ನೋದನ್ನ ಹೇಳಬೇಕಾದ್ರೆ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಇದೆಯಾ ಇಲ್ವಾ ಅನ್ನೋದು ಇಂಪಾರ್ಟೆಂಟ್ ಆಗತ್ತೆ, ರೈಟ್? ಹಾಗಾಗಿ ಫಸ್ಟ್ ನಮಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ನೋಡೋಣ. How were we defining electric field? If you recall electric field, it is the space around a charge where a test charge experiences a force. So if I take a charge, it is the space around the charge where a test charge experiences a force. So for that, I need to bring a small test charge, say Q, closer to this first charge, which is the source charge. So let me call this as the source charge. because this is the source of electric field. This particular charge is producing the electric field, so I am calling it as the source charge. So in order to find out whether there is a field at this point or not, what I'll do is I'll bring a test charge here and I'll see whether there is a force. So if I feel no force, if I say force is 0, then what I'll say, the field here is 0. There is no electric field at this particular point. Now let me bring that charge to some other point, say this point P. Okay. Now if the charge experiences a force F, then I'll say there is a field, right? So if the charge experiences a force, then I'll say there is a electric field in this particular region, right? ಹಂಗಂತ ಹೇಳಿದ್ರೆ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದೆಯಾ ಇಲ್ವಾ ಅನ್ನೋದನ್ನ ನಾವು ತಿಳ್ಕೊಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡ್ತೀವಿ, ಅಲ್ಲಿ ಒಂದು ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ನ ತಂದು ಇಡ್ತೀವಿ. ಆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಮೇಲೆ ಫೋರ್ಸ್ ಬೀಳಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಆಗ ನಾವ್ ಏನಂತ ಕನ್ಕ್ಲೂಡ್ ಮಾಡ್ಬೋದು, ಅಲ್ಲಿ ಯಾವುದೇ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಲ್ಲ ಅಂತ ಹೇಳ್ತೀವಿ. ಅದೇ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಿದ್ರೆ ಚಾರ್ಜು, ಆಗ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಆ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದೆ ಅಂತ ನಾವು ಕನ್ಕ್ಲೂಡ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ದಿ ಚಾರ್ಜ್, to find out the force, we used to use Coulomb's law, and using Coulomb's law we can find out the electric force, which we have already discussed in the last session. And using Coulomb's law, the force acting on this particular test charge was found out to be how much? F is equal to Q into E. So how did we come to this equation? For that you can check the last video. So let me write the formula here. Force between two charges is given by 1 by 4 pi epsilon naught Q1, Q2. In this case, Q1 is nothing but the source charge, Q2 is nothing but the test charge, and R square is the distance between the two charges. So using this equation, I can write the formula for force as F is equal to Q into E, right? Now I can define electric field using this formula. So what will be electric field? So the electric field E can be written as F by Q. So it is the electric force which is experienced by a unit positive test charge, right? This is how we define electric field. So electric field andre enu? It is the force experienced by a unit positive test charge. That is how we define electric field. It is very important to note that what will be the direction of electric force. If we look at the direction of electric field and electric force, both will be in the same direction. And also it is very important to note that the electric force here is not dependent on velocity. It is only dependent on the charge and it is only dependent on the field, right? So electric force endra ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಿದೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಬರೀ ಅಲ್ಲಿರುವಂತ ಚಾರ್ಜ್ ನ ಸ್ಟ್ರೆಂತ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಾ ಇದೆ, and it is dependent only on the electric field. It has nothing to do with the motion of the charge. So I can conclude by saying that electric forces are independent of velocity of the particle, right? ಸೊ ಇಲ್ಲಿ ಈ ಪಾರ್ಟಿಕಲ್ ಮೇಲೆ ಬೀಳ್ತಿರುವಂತ ಫೋರ್ಸು ಏನ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಿದೆ, ಈ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಿದೆ, ಮತ್ತೆ ಈ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಇಂದ ಎಷ್ಟು ದೂರದಲ್ಲಿ ಇದೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಾ ಇದೆ. ಈ ಎರಡನೇ ಚಾರ್ಜ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದೆಯಾ ಅಥವಾ ಮೂವ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇದೆಯಾ ಅನ್ನೋದ್ರ ಮೇಲೆ ಫೋರ್ಸು ಡಿಪೆಂಡ್ ಆಗ್ತಾ ಇಲ್ಲ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸಸ್ ನಾವು ಏನಂತ ಕರಿಬಹುದು, ಇಟ್ ಇಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಅಂತ ನಾವು ಕರಿಬಹುದು. What about the direction? So direction na artha ಮಾಡ್ಕೊಳಕ್ಕೆ let us consider a case where I am placing a charge in a electric field. So there is a positive charge Q. Now I am placing that in an uniform electric field. So this is a region which has a uniform electric field E, and we are representing the field by field lines. Okay. Now what happens to this charge Q? Obviously, this is an electric charge which is placed in the electric field. It will experience a force. And what will be the direction of force? The direction of the force will be same as the direction of the field. And what about the magnitude? The magnitude of the force is given by Q into E. So whenever we place an electric charge in electric field, it will experience a force which is equal to Q into E, and the direction of the field will be, if it is a positive charge, the direction of force will be same as direction of the ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ನ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಫೀಲ್ಡಿನ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೇ ಒಂದು ಫೋರ್ಸ್ನ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡುತ್ತೆ. ಆ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡೋ ಫೋರ್ಸ್ ಇಂದ ಏನಾಗುತ್ತೆ, ದಿಸ್ ಪಾರ್ಟಿಕಲ್ ಆಕ್ಚುಲಿ ಸ್ಟಾರ್ಟ್ಸ್ ಮೂವಿಂಗ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಏನ್ ಮಾಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡು ಒಂದು ಪಾರ್ಟಿಕಲ್ನ ಆಕ್ಸಲರೇಟ್ ಮಾಡಿಸುತ್ತೆ. So the electric field will produce acceleration in a charged particle. What if it was a negative charge? If I place a negative charge in the electric field, again the negative charge will also experience a force which is equal to Q into E, but the direction will be opposite to that of the positive charge. Therefore, the force will be in opposite direction to the field. So here the direction of the force will be opposite to the direction of electric field. ನಾವು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ನ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಅದ್ರ ಮೇಲೆ ಕೂಡ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಬೀಳತ್ತೆ. ಆದರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಅದು ನಮ್ಮ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಿನ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಆ ಫೋರ್ಸ್ ಬೀಳತ್ತೆ. ಅಗೇನ್ ಈ ಫೋರ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಆ ಫೋರ್ಸ್ ಆ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ನ ಆಕ್ಸಿಲರೇಟ್ ಮಾಡಿಸುತ್ತೆ. ಈವನ್ ದೋ ವಿ ಹ್ಯಾಡ್ ಕೆಪ್ಟ್ ದ ಚಾರ್ಜ್ ಅಟ್ ರೆಸ್ಟ್, at the beginning, say the charge was at rest or the velocity was 0, the moment we place that charge in the field, that field will make the charge to accelerate and the charge will start to move. So ಒಂದು ಚಾರ್ಜ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದ್ರೂ ಕೂಡ ಏನ್ ಮಾಡುತ್ತೆ, ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇಟ್ಟಿದ ತಕ್ಷಣ ಆ ಚಾರ್ಜು ಮೂವ್ ಮಾಡಕ್ಕೆ ಶುರು ಮಾಡುತ್ತೆ. ಸೊ ದೀಸ್ ಆರ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ರಿಗಾರ್ಡಿಂಗ್ electric fields and electric forces. Let us use a similar approach to define magnetic field. So to define magnetic field, first we have to define what is magnetic force. Using the knowledge of magnetic force, we can define magnetic field, just like what we did with electric fields. Okay, let us start with a magnetic force. For that, let me consider a positive charge Q. Let me place this particular charge in a magnetic field. Say there is a magnetic field, uniform magnetic field B in this particular region, and that is represented by this particular blue line. Now I am placing this charge Q on this region where there is a field. Now I'll see whether there is a magnetic force. So what is my observation? Have placed a charge in the region of magnetic field, so the velocity is 0 because the charge is at rest. Experiment shows that it will not experience any force. The magnetic force on this particular charge is 0 ಅಂತ ಹೇಳಿದ್ರೆ, ಒಂದು ಚಾರ್ಜ್ನ ತಗೊಂಡು ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇರುವಂಥ ರೀಜನಲ್ಲಿ ಆ ಚಾರ್ಜ್ನ ಇಟ್ಟು ನೋಡಿದಾಗ ಆ ಚಾರ್ಜ್ ಮೇಲೆ ಯಾವುದೇ ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸು ಬೀಳೋದಿಲ್ಲ. So there is no magnetic force on a charge which is at rest. What is happening here? It is very easy to understand that, because if a charge is at rest, it is only producing electric field. Therefore, it is not interacting with the external magnetic field. ಒಂದು ಚಾರ್ಜ್ ರೆಸ್ಟಲ್ಲಿ ಇದ್ದಾಗ ಅದು ಕೇವಲ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನ ಮಾತ್ರ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಹಾಗಾಗಿ ಹೊರಗಡೆ ಇರುವಂಥ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಜೊತೆ ಅದು ಇಂಟರಾಕ್ಟ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಅದೇ ಈ ಚಾರ್ಜ್ ಇವಾಗ ಮೂವ್ ಆಗೋಕ್ಕೆ ಶುರು ಮಾಡಿದ್ರೆ, along with the electric field, it will also produce a magnetic field. Then it can interact with the external field. So, in the second case, what I'll do is, I'll make this charge to move with some particular velocity. Now, the charge is moving in the presence of magnetic field, and it is moving with a velocity v. Now, the experiment shows that this particular charge will experience a force, magnetic force. Okay, ಒಂದು ಚಾರ್ಜ್ ಯಾವಾಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಮೂವ್ ಮಾಡೋಕ್ಕೆ ಶುರು ಮಾಡುತ್ತೋ ಆಗ ಆ ಚಾರ್ಜ್ನ ಮೇಲೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡು ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಿಂಗ್ ಅ ಫೋರ್ಸ್, and this particular force will start deflecting the charge from its initial direction. So there will be a deflection, and this deflecting force is called as the magnetic force. The force that is deflecting the charge from its original direction is called as the magnetic force. The speciality of magnetic force is it has a directional character. We'll say the magnetic force has a directional character. That means both the magnitude as well as the direction of this force will depend on the motion of this particular particle. ಅಂತ ಹೇಳಿದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ನ ನಾವು ಡೈರೆಕ್ಷನಲ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇರುವಂಥ ಫೋರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಏನು ಬರುತ್ತೋ ಅದರ ಡೈರೆಕ್ಷನ್ ಇರ್ಬೋದು ಅಥವಾ ಅದರ ಸ್ಟ್ರೆಂತ್ ಇರ್ಬೋದು, ಅದು ಈ ಚಾರ್ಜ್ ಯಾವ ರೀತಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಇಟ್ ಹ್ಯಾಸ್ ಅ ಡೈರೆಕ್ಷನಲ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳಕ್ಕೆ let us come back to the same equation. Let us come back to the same example. So there was a charge which was moving with some velocity v in the presence of a magnetic field b, and it is found experimentally that the magnetic force which is acting on this particular charge is given by F, which is equal to Q into V cross B. So this is the magnetic force on a moving charge. And if I only look at the magnitude of the force, the magnitude of the magnetic force is given by Q into, what is V cross B? This is a cross product, so I can write it as QVB sine theta. Why is that? If I have the cross product of two vector A cross vector B, then I can write this as AB sine theta into n cap, where n cap gives me the direction of the new vector, right? So it gives the direction of A cross B vector. Here I am only talking about the magnitude. So the magnitude of the force is given by QVB sine theta. What does that mean? We can easily observe that the magnetic force is depending on Q. The magnetic force is also depending on the strength of the magnetic field. And a very important observation is the magnetic force is actually depending on the velocity of this particular charge. We know in case of electric field, let me write it here. If it was a charge placed in electric field, the electric force is given by Q into E, right? The electric force depends on the charge, the electric force depends on the field. So similarly, the magnetic force depends on the charge and the magnetic force depends on the magnetic field. The most important difference between electric field and the magnetic field is, or the electric force and the magnetic force is, the magnetic force is actually depending on the velocity of the body. So F is directly proportional to V. ಅಂತ ಹೇಳಿದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಏನಿದೆ ಅದು ಚಾರ್ಜ್ನ ಸ್ಟ್ರೆಂತ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ 5 ಕೂಲಮ್, if I increase the charge to 15 coulomb, magnetic field will increase, right? So if I increase the strength of the magnetic field, again the magnetic force which was deflecting this particle, again that force will increase. That is similar to electric field. ಆದರೆ ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಏನಿದೆ ಅದು ಈ ಚಾರ್ಜ್ ಯಾವ ರೀತಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಯಾವ ಸ್ಪೀಡಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ, ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಿದೆ, ವಿಚ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ವೆಲಾಸಿಟಿ. And it is also depending on theta, that means it is depending on the direction of motion of the charged particle. Now let us try to find out the direction of magnetic force. So what will be the direction of magnetic force? The magnetic force is given by Q into V cross B. Therefore, the direction of the force will be in the direction of this cross product. So how will be this cross product? So this was the direction of the magnetic field B, and the charged particle was moving in this particular direction, so which is V. And where will be V cross B? How will you find out the vector product? For that we use right hand thumb rule, right? So what does right hand thumb rule states? So it states that if you start from the first vector and if you curl the fingers of your right hand towards the second vector, then in whichever direction your thumb is going to stretch, that is going to give you the new vector A cross B. In this case V cross B, right? So you should start from vector V and you should curl your fingers towards vector B. Then if you look at your finger, it is going to be curled in this particular direction. So the force will be in this particular direction. So this will be V cross B. So using the right hand rule, now I found out the direction of magnetic force which is acting on the charge. If you observe, this magnetic field is actually at an angle 90 degree to the motion of the particle. So this is very important. ಸೊ ಇಲ್ಲಿ ನಾವು ನೋಡಿದಾಗ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಯಾವ ಕಡೆ ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಯಾವಾಗಲೂ ಈ ಚಾರ್ಜ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿರತ್ತಲ್ಲ ಅದಕ್ಕೆ ಯಾವಾಗಲೂ ರೈಟ್ ಆಂಗಲ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ is always at right angle or 90 degree to the velocity vector, or I can say magnetic force will always be perpendicular to the velocity of the motion of the particle. So this is very interesting. Irrespective of whatever direction the charge is going to move, the force will always adjust itself so that it becomes perpendicular to the direction of velocity vector. That is the beauty of magnetic forces. Let us understand this with an example. Say this is the magnetic field. Now our charge is actually moving in this particular direction. Now what will be the direction of magnetic field? Use the right hand rule. So look at where will be V cross B. So V cross B will be upward. So this is the magnetic force. Now I'll say the same charge Q, instead of coming in this direction, what if it goes in the other direction? So this is the magnetic field B. Now the charge will start moving in this direction, which is opposite to the initial direction. Now what will happen to the field? Now again use the right hand thumb rule. Curl your fingers from V to B. Now your thumb will be pointing downwards. So this will be the direction of V cross B. That means the magnetic force will reverse its direction. What about the strength? Here, the strength of the magnetic field is given by QVB sine theta, right? So I have to just look at this angle theta and then I'll get the value for the magnetic force. Let me take one more case. Say in this third case, magnetic field is perpendicular to the screen. So ನಾನು ಮೂರನೇ ಕೇಸಲ್ಲಿ ಏನು ಮಾಡ್ತಿದ್ದೀನಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡು ಈ ಸ್ಕ್ರೀನ್ ಒಳಗಡೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಬೀಳ್ತಾ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. And there is a charge which is trying to move in this particular direction. What will be the direction of force? So the direction of B is, let me write the axis here. This is X, this is Y, and the magnetic field is actually in the Z direction. So what should be the direction of the force? It should be in the Y axis, right? Because the magnetic field is in Z axis, the particle is moving in the X axis. Therefore, the axis which is perpendicular to both the B and V is Y axis. Therefore, the force will now be acting upwards. So this will be the magnetic force. So what will this magnetic force do to this charge? It will make the charge move in some other direction. It will deflect the charge from its initial direction. So magnetic force deflects the particle, whereas electric force actually accelerates the particle. So what will magnetic force do? It will only deflects. It does not produce any acceleration. There is no acceleration. Okay, ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಚಾರ್ಜ್ ಮೂವ್ ಆಗ್ತಾ ಇದ್ರೆ ಅದು ಕೇವಲ ತನ್ನ ಒರಿಜಿನಲ್ ಡೈರೆಕ್ಷನ್ ಇಂದ ಡಿಫ್ಲೆಕ್ಟ್ ಆಗುತ್ತೆ, ಬಟ್ ಅದು ಆಕ್ಸಿಲರೇಟ್ ಆಗಲ್ಲ. ಆದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ನ ನೋಡೋದಾದ್ರೆ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರೋ ರೀಜನ್ ಅಲ್ಲಿ ಏನಾದ್ರೂ ಚಾರ್ಜ್ ನ ಹಾಕಿದ್ರೆ ಅಲ್ಲಿ ಆಕ್ಸಿಲರೇಷನ್ ಆಗೋದನ್ನ ನೋಡ್ತೀವಿ. Okay, so that's one of the important difference between electric field and the magnetic field. So now we know what will be the magnetic force which is acting on a charged particle. Now let us look at some special cases. If the velocity and the magnetic field are at right angle to each other, then what will happen to the magnetic force? So if the velocity and B are at right angle, then V cross B, how do you write magnetic force? Magnetic force is equal to Q VB sine theta, where theta is the angle between V and B. Now the statement is saying that velocity and the magnetic field are at right angle. That means in this particular case, theta is equal to 90 degree. So if I substitute sine 90, it will become 1. So the force, magnetic force will become QVB. So this is the maximum force that a particle can experience when it is in a magnetic field. So ಒಂದು magnetic field ಇರುವಂತ region ಅಲ್ಲಿ ನಮ್ಮ particle ಫೀಲ್ಡ್ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಮೂವ್ ಆದರೆ ಆಗ ಅದರ ಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಬೀಳುತ್ತೆ. ಸೊ ದ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಂಡ್ ಇಟ್ ವಿಲ್ ಬಿ ಗಿವನ್ ಬೈ QVB. Of course, for the direction of the force we need to use right hand thumb rule, right? What about the second case? The charged particle is moving parallel to the magnetic field. So there is a magnetic field, say it is in this particular direction. Now there is a charge which is moving in the same direction as the field. Now the charged particle is moving parallel to magnetic field. What will be theta? In this particular case, theta is 0. If I substitute the value of sin 0 is 0. Therefore, the force becomes 0. What does that mean? If a charged particle moves in the direction of field, it will not experience any force. This is true even if it was moving in anti-parallel direction. So now the angle become 180 degree. Again, sin 180 is going to become 0 and the force on this charge is still 0 only. So if a charge moves in the direction of field or opposite to the direction of field, it will not experience any force. Okay, because the magnetic force is direction dependent. It is important to look at the angle theta. If the theta is going to become 0 or 180, the force is going to vanish. Okay, now what if the charge is at rest? We have discussed it already. If the charge is at rest, if velocity is 0, then the whole thing is going to become 0. So 0 into anything is 0. Therefore, the magnetic force is going to become 0. The charge will not experience any magnetic field. What if the particle has no charge? What if the particle is neutral? That will be the last case. So if Q is equal to 0, if the body doesn't have any charge, even then this QVB sin theta is going to become 0 and the magnetic force on a neutral particle will be 0. A chargeless particle will never experience a magnetic force. A chargeless particle will never experience a magnetic force. Andre ಚಾರ್ಜ್ ಇಲ್ದಿರುವಂಥ ಪಾರ್ಟಿಕಲ್ನ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡಲ್ಲಿ ಹಾಕಿದಾಗ ಅದರ ಮೇಲೆ ಯಾವುದೇ ಆದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸು ಬರೋದಿಲ್ಲ. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಅದಕ್ಕೆ ಒಂದು ಚಾರ್ಜ್ ಇರಲೇಬೇಕು. ಮತ್ತು ಆ ಚಾರ್ಜ್ ಏನಾಗಬೇಕು, ಆ ಚಾರ್ಜು ಮೂವ್ ಆಗ್ತಾ ಇರಬೇಕು. ಮತ್ತು ಮೂವ್ ಆಗಬೇಕಾದ್ರೆ ಅದರ ಡೈರೆಕ್ಷನ್ ಕೂಡ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಅದು ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಫೀಲ್ಡ್ ಅಥವಾ ಆಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಫೀಲ್ಡ್ ಮೂವ್ ಆದರೆ ಆ ಕೇಸಲ್ಲೂ ಕೂಡ ನಾವು ಯಾವುದೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ನ ನೋಡೋದಿಲ್ಲ. ರೈಟ್, ಇಟ್ ಹ್ಯಾಸ್ ಟು ಮೇಕ್ ಸಮ್ ಆಂಗಲ್ ಥೀಟಾ ವಿಚ್ ಇಸ್ ನಾನ್ ಝೀರೋ ವಿತ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ನಾವು ಹೇಳ್ಬಹುದು. ಸೊ ನೌ ವಿ ನೋ about magnetic forces. With this knowledge, we can now define what is magnetic field. Now let us define magnetic field. Magnetic field is also called as magnetic induction. So how to define a magnetic field or magnetic induction at a point? For that, we need to first write down what is magnetic force. So magnetic force is given by the equation QVB sin theta. For simplicity, we'll make theta as 90 degree, where theta is nothing but the angle between V and B. So that sin 90 is 1. So the equation reduces to QVB whenever the angle between V and B is 90 degree or V and B are perpendicular to each other. So using this equation, now I can define the magnetic field. The magnetic field can now be written as magnetic force by Q into P. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನ ನಾವು ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನು ಮಾಡಬೇಕು, ಮೊದಲು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ದು ಫಾರ್ಮುಲಾ ಬರೆಯೋಣ. ಅದಾದಮೇಲೆ ಯೂಸಿಂಗ್ ದಟ್ ಫಾರ್ಮುಲಾ ವಿ ಕ್ಯಾನ್ ಡಿಫೈನ್ magnetic field. So magnetic field becomes numerically equal to magnetic force ಯಾವಾಗ, whenever Q is becoming 1 and V becomes 1. And of course, V and B must be perpendicular to each other. Therefore, theta must be equal to 90 degree. Magnetic field becomes numerically equal to magnetic force whenever 1 coulomb of charge moves with a velocity of 1 meter per second at a direction perpendicular to the magnetic field. Then we say the magnetic force becomes equal to magnetic field. So I can define the magnetic induction as numerically equal to magnetic force experienced by a unit charge. Unit charge means 1 coulomb of charge moving with unit velocity. Unit velocity means it is moving with a velocity of 1 meter per second. How? At an angle of 90 degree or at a direction perpendicular to the magnetic field ಅಂತ ಹೇಳ್ಬೋದು. What about the SI unit of magnetic field? We know the SI unit of magnetic field is Tesla. So how to define Tesla? Just now we defined magnetic field as numerically equal to magnetic force. Therefore, magnetic field is called as 1 Tesla whenever a charge of 1 coulomb experiences a force of 1 Newton when it is moving with a velocity of 1 meter per second at a direction perpendicular to the magnetic field. So if this is the magnetic field and if you have a charge which is 1 coulomb and if it is moving at an angle of 90 degree to the field at a velocity of 1 meter per second, if in this case the force that is acting on this charge is 1 Newton, then we'll say the field is actually 1 Tesla. So magnetic field na 1 Tesla anta yavag karitivi? 1 coulomb of charge magnetic field ge perpendicular agi 1 meter per second velocity alli move ಆದಾಗ ಅದರ ಮೇಲೆ 1 ನ್ಯೂಟನ್ ಅಷ್ಟು ಫೋರ್ಸ್ ಬಿದ್ದರೆ ಆಗ ಅಲ್ಲಿರುವಂತ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ನ ನಾವು 1 ಟೆಸ್ಲಾ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ವಿ ಡಿಫೈನ್ 1 ಟೆಸ್ಲಾ. ಸೊ ನೌ ವಿ ಹ್ಯಾವ್ ಡಿಫೈನ್ಡ್ ವಾಟ್ ಇಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ and also we have defined what is magnetic forces. Now let us look at the difference between electric and magnetic forces. Electric force is given by Q into E. Similarly, magnetic force is given by Q into V cross B. What about the direction of magnetic force? Magnetic force always acts in the direction of field. So the direction of force will be same as direction of electric field. What about the direction of magnetic force? So the direction of magnetic force is always perpendicular to the direction of motion of the particle, right? What about the velocity? Electric force is independent of the velocity, so it will not depend on the velocity, whereas magnetic force depends on the velocity of the particle. And also, electric force produces an acceleration in the particle. So it will produce an acceleration in the particle, whereas magnetic force does not produce any acceleration in the particle, but what will it do? It will distort the direction, or it will produce a deflection. It will not change the velocity of the particle. So the velocity of the particle remains a constant if it is moving in a magnetic field, but the magnetic force will deflect the particle from its original direction. So these are the important differences between electric force and the magnetic force. Now coming to the most important topic, Lorentz force. So what is Lorentz force? In order to understand Lorentz force, let me first consider a charge. Say this is a positive charge, and it is placed in a region which is consisting of both electric field and magnetic field. Say ಇಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ಇದೆ, ಇದನ್ನು ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎರಡೂ ಇರುವಂಥ ಒಂದು ರೀಜನಲ್ಲಿ ಇಟ್ಟಿದ್ದೀವಿ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. So for our convenience, let me take the electric field is in this particular direction. And the magnetic field is going into this plane. Okay. The magnetic field is perpendicular to the plane of this board, and it is moving into it. So magnetic field is in this particular direction. It is moving into the screen. ಇಂಥ ಒಂದು ರೀಜನ್ ಅಲ್ಲಿ ಈಗ ಈ ಚಾರ್ಜು ಮೂವ್ ಆದ್ರೆ, ಸೇ ಇಟ್ ಇಸ್ trying to move in this particular direction, what will happen to this charge? So there is an electric field and there is an electric charge. Definitely because of the electric field there will be an electric force. So what will be the force? The electric force acting on the charge particle is given by F is equal to Q into E. Now the charge particle is moving in a region which also has a magnetic field, right? Therefore the magnetic field will also put some force on this particular charge. So what will be the magnetic force acting on a moving charge? That is given by Fm, which is equal to Q into V cross B. Now there are two forces, Fe and Fm, which is acting on this particular charge, and both the forces are vectors. So the total force that is acting on this charge, for that we have to take the vector addition, and the resultant force that we get is called as the Lorentz force. So Lorentz force is nothing but the resultant force that acts on a charged particle which is moving in a space which is containing both electric field as well as the magnetic field. So how do I find out the resultant force or the total force? So the Lorentz force is equal to electric force plus magnetic force, so which I can write it as QE plus Q into V cross B. I can take Q as common factor, so Q into E plus V cross B. This is called as F vector, and this is the Lorentz force. So this resultant force is called as the Lorentz force. So to sum up what we learned today, we have learned what is a magnetic force, right? So what is a magnetic force? It is a force which is acting on a charge which is moving in a magnetic field, and the magnetic force is given by Fm, which is equal to Q into Vb sine theta, where theta was the angle between velocity vector and the magnetic field. And we also defined magnetic field in terms of magnetic force, and the magnetic field is numerically equal to magnetic force whenever the charge and the velocity turns out to be unity, and theta must be equal to 90 degree. And we also discussed about the difference between electric field and the magnetic field. The key point is electric field produces acceleration, whereas magnetic field only changes the direction of motion of the particle, and electric force will not depend on the velocity, whereas magnetic force depends on the velocity of the particle. And last we discussed about Lorentz force. What is Lorentz force? It is a resultant force which is acting on a charge which is moving in a region which is consisting of both electric field as well as the magnetic field. So we talk about Lorentz force especially in cyclotron. You might have learned about cyclotron in your PUC. There used to be two D's, right? And you used to apply both electric field and magnetic field in order to accelerate charged particles. So there is wide variety of application for Lorentz force. So that is for today. So these are my references. Thank you.